So here the types of error values are listed. First of all, we may have such kind of error in Excel. The name is division by zero. So if you divide by zero, for example, A1 is, let's say, 1, B1 is 0, then you will have such error. So the next error is called name, and it results when a formula contains an undefined variable or function name. So also we have the following error values. N/A, no value is available. Null, a result has no value. Or numerical overflow, for example, a cell with square root t, actually z1, when z1 has a negative value. Of course, if you compute, or if you try computing square root of, for example, -10, you will have such an error value. So the next one is invalid argument type, or value, right? Value. So dear students, please be careful with these error values. If you have one, I suggest you to open my presentation and check what kind of error value it is. Okay? Also, one error value is related to invalid cell reference. So if you use some wrong reference to a cell, or with some probably mistakenly written, then you'll have this invalid cell reference. So last time I have shown you how some function works. I think we can simply skip of this. Again, we can use several methods. Use some function, or you can actually add two cells, or you can add two numbers separately, or you can use AutoSum tool. Again, I would like to remind you, where is AutoSum? So in the Home tab here, you will find AutoSum. Okay, so you will select the range, click on AutoSum, and it will compute the result. Okay, so this is related to addition. Addition operation. So you know, addition is one of mathematical operations. Also we have subtraction. So subtraction means minus, right? Addition means plus. Also we have multiplication. Multiplication means to multiply, right? Numbers. Let's say if you want to multiply, let's say 5 times 6, so you can call this multiplication operation. Moreover, we have division operation. For example, 11 divided by 2, right, is operation of division, right? I will write it here. So division operation. So division has several meanings, so you need to find the correct one. Okay, so the next function, dear students, is called average. So it's useful for computing the average or arithmetic mean of the given arguments. Average, or we can also call it mean value. So for example, if the range A1 to A20 contains numbers, the formula equal average, and in parentheses we write down only one argument, the range of cells. So this formula will return the average of given numbers. So the syntax is shown here. Again, please don't forget, all formulas should start with the equal sign. Okay, equal sign. If there is no equal sign, then it won't work. So as minimum, it should have one argument. So here we can see only one argument. If you have more arguments, they will be separated by comma, right? So here we don't have any commas. So that means we have one argument here. So now let's try to test this function. Again, the name of this function is average. Okay, let me input some numbers here, like 5, 6, 3, 2, and 1. So now I want to compute the average value. Average value will be written here. Let me emphasize it. So I will start with typing formula. Again, I need to type first the equal sign, then average, parentheses. Then I will select this range. I'll select the range from A1 to A5. Don't forget, we use column here, right? So then close the parentheses, closing parentheses, okay, and enter. So this is very simple syntax of this function, average. So again, the first argument is required, so you need to have minimum one argument. So other arguments are optional, so you can add them, or maybe you don't want to add them. So don't forget to use commas if you use different arguments, different number of arguments. So the next one is a count. This is the name of the function. So the count function counts the number of cells that contain numbers and counts number with a list of arguments. So let's do a simple example. I'll return to Excel here and let me delete this. Okay. So now I will use different inputs like text, for example, and numbers, let's say. And let me center it also. Okay, 0. So now let me apply count function. Again, equal sign, count, opening parentheses, and I will select the range A1 to A6. Okay, I use only mouse here. Then don't forget to close the parentheses and enter. So as a result, you will have 4. So what does it mean, 4? So in this range, how many cells do we have which contain numbers? So we have 1, right? We have 2, we have 3, and we have 4. So we have totally 4 cells. So other cells, like this one and this one, they contain text. So if you change something here, for example, if you type something, then number of cells which contain numbers will change, right? We'll have 1, 2, and 3. So again, the count function counts the number of cells that contain numbers and counts numbers with the list of arguments. I think it's a clear example. So the next function is known as a max. So is used to compute the largest value in a set of given values, the largest value, or you can call this maximum. You know what is a maximum, right? So look here at the syntax. Again, we will start with equal sign here. I don't write it, but you need to understand that all functions, they have to start with equal sign. So this is compulsory argument, and these are optional. These are optional. It means you may have them or you may not have them. So you can input the set of values. Set means several group of values. So we can also test this function, and let's see how it works. Okay. So okay, instead of writing some text, I'll write numbers here, 3, 10, and let's say 11. Okay, I'll delete this function from here. Okay, so instead of count, I'll use max function, max. So, and here I will use only one argument, the range from A1 to A6. Okay, only one argument. Enter. So max function says that the maximum value in this set of numbers, so this is a set. Set means a group of numbers, a collection of numbers. So the maximum value is 11. So in the similar way, we can compute the smallest value. Smallest value. Smallest means the minimum value. Minimum value. Please check out the translation here. And so for computing the smallest value, I will use min function. Again, equal min, and I will define the range of given numbers. Okay, enter. So minimum value is 0. You can see, so this is the smallest value in a given set of numbers. So such functions are often used in mathematics, in statistics, and also by engineers. So you can have a large set of numbers, and you can easily compute what is the highest, what is the largest value, and what is the smallest, what is the minimum value. So you don't need to do this manually. So if you have such a great tool as electronics spreadsheet. So the next topic, dear students, is related to trigonometry functions. Trigonometry functions. I think you understand what is trigonometry. Trigonometry is a branch of actually school maths. So where actually they study some basic trigonometric functions. So here on this slide you'll find functions such as sine function, cosine function, right? Tangent function. Let me write it. Sine function, right? Sine hamsu. Cosine function. Cosine hamsu, right? You understand this. Also, we have a tangent function. And we have some other functions like secant function, cotangent function. Here we have a triangle with right angle. So this angle is equal to 90 degrees, as you know from here. So this angle is 90 degrees. So this is a right angle. So it means angle with 90 degrees. So if you consider such a triangle, and let's say you want to consider this angle A, okay, angle A. So how to compute the sine of this angle, sine of angle A? You can see this formula. So we need to divide the opposite side. This is the opposite side. BC is opposite side over hypotenuse. I think it should be also translated. So opposite side. So we will divide opposite side, right, by over hypotenuse. Okay. Even you can find some translation here. It's not a hypothesis. Okay, it's wrong translation here. Hypotenuse is a name of this side. Okay, name of this side. So you will divide. If you divide A by C, then you will find the sine of angle A. Okay, of this angle. So if you want to find the cosine of angle A, right? So you need to divide adjacent side. This is, so B side is called adjacent side, okay? So it's nearby angle. So you'll divide this over hypotenuse, over C, B over C. So this is, just look here, tangent of angle A, right? So to find tangent, we divide opposite side A by adjacent side by B, right? As a result, we'll get tangent alpha. So cotangent is adjacent side over opposite side. Okay, you can also find secant and cosecant values here. Of course, well, the process is also explained here. You can look at this picture. I think it illustrates well what is a basic trigonometric functions like cosine, like sine, and like tangent. Of course, here we have an angle, so theta, right? So tangent of theta is this one, opposite side divided by adjacent side, and etc. So please look here. This is just a reminder for you. I think some of you have already studied this in your high school. Also, you can find some values of trigonometric functions in this table. So angles are given in degrees. For example, sine of 0 degrees is equal to 0. Cosine of 0 degrees is equal to 1. Tangent is equal to 0. And so these are undefined, and etc. So I think this table can also be useful for you. So the question is, how do we compute these functions in Excel? Until 2013 version, Excel trigonometry functions were cosine, sine, and tangent together with inverse functions such as arccosine, arcsine, and arctangent. So we have trigonometric functions, and also we have inverse trigonometric functions. So in Excel 2013, we have a much fuller range of functions. So you can access them in formulas, functional library, and mathematics and trigonometry to see what is available. So let's check out together. Okay, let me delete this. I think we don't need this. Delete. So just click here, insert function, insert function. Okay, here we have different categories. So most recently used. So we need to find mathematical and trigonometric functions. Okay. Okay. And all the functions can be found here. So you will find all functions related to mathematics and trigonometry. Okay. So moreover, I would like to remind you that usually we deal with degrees and radians when we study trigonometric functions. So degree, you know what is a degree, and also there is another measure, it's called radian. Radian. So the question is how degrees and radians are related to each other. So here I have provided you with the degrees to radians conversion scale. So using this scale, you can easily convert from radians to degrees. For example, 0 radians is equal to 0 degrees, right? So then, for example, 2 radians is approximately equal to, let's say, 115 degrees, right? And etc. So you can understand. So if I'm saying to you, okay, I want to compute 4 radians, 4 radians. 4 radians. Then you need to understand what I'm talking about. So I'm talking about something like here, right? A little bit more than 230 degrees, right? So this scale will help you to understand actually the relationship between degrees and radians. Okay, again, so they are translated here. So moreover, there is a good formula. So which says that I will emphasize this here. So 1 radian is equal to 180 degrees over pi. Okay, 1 radian is equal to 180 degrees divided by pi. Okay, so what does it mean? So pi radians is equal to 180 degrees. Okay, so please don't forget this formula. Okay, this is very important. So here we have radians. Okay, here we have a radian. And on the right hand side we have degree. Okay. Okay. If pi radians is equal to 180 degrees, right? So it's somewhere here, right? Somewhere here. Okay. How about 2 pi? So if pi is equal to 180, 2 pi will equal to how many degrees? So you will multiply 2 by 180 and you'll have 360 degrees, right? 360 degrees. 360 degrees is somewhere here. So it will be more than 6 radians. So again, this is the main formula. And if you forget this formula, then you cannot easily convert to degrees or to radians. Again, dear students, so pi radians is equal to 180 degrees. Okay, 180 degrees. So let's say you want to compute, for example, 30 degrees. 30 degrees. How many radians? How many radians? So you will construct such kind of proportion. 180 degrees is pi radians, right? Pi radians. So from this proportion, you will find that unknown is equal to 30 times pi divided by 180. 180 degrees, right? So here, what we'll have? We'll have 30, so we can make some simplifications. So 1 divided by 6, right? 6. So as a result, we'll have pi over 6. Pi over 6 is equal to 30 degrees, okay? So you can use such very simple computations. Okay, so if you don't understand this well, I think better is to use Microsoft Excel to convert from degrees to radians. Let me show it to you. Actually, Excel has two functions, degrees and radians. So let's say I have degrees here, 30, 60, 90, 120. Okay, these are degrees. So I want to convert them to radians. So the question is, how can I do this? Okay, I will use all borders. So if you want to compute radians, then you have to use some specific function for this. So equal radians, okay, radians function. It will convert degrees to radians. So input should be degree, right? Input should be degree. We should have only one argument here, right? One argument. And output will be radians. So here I will write just a reference to a cell B2, right? B2. Okay, closing the parenthesis. So please look what I have here. Again, function name is radians. Enter. So as a result, I could convert it to radians. So you can easily copy down your formula. So here we don't use an absolute reference. So there is no absolute reference here. So that means if you copy the formula, then a reference to the cell will change. Instead of B2, we'll have B3, right? Then B4, and etc. So let me copy it. I will just bring my cursor here and drag it down here. Okay, now everything is computed. Also, I can change the number of decimal places by defining only, let's say, 3. Okay, 3. Okay, now it looks much better. So degrees were converted to radians. Also, if you have something given as radians, you can convert them to degrees. And I'm going to show you how you can do this. Okay, let's say we have angles given in radians, and we need to convert to degrees. Okay, let me use borders here. All borders, all right. Okay, suppose that I have radians. Let's say I will copy them from here. Okay, enter. I'll use the same values and copy them down. So now I will convert these values to degrees. So for this purpose, I will use degrees function equal degrees function. So it converts radians to degrees. Okay, so the syntax is exactly the same. I need to use one argument. So here I will use E3, right? This cell, E3. E3. Okay. So then I can press enter. Okay, now it's computed. So now I will copy this formula to remaining cells. So 0.524 radians is equal to 30 degrees, and etc. So if you change something here, let's say 0.6, right? And also we will have different values. We'll have different values. Okay, so also you can format these cells and use 3 or less decimal places. So again, number, category here, number of decimal places. Okay, so this is how it works, dear students. If you don't know how to do this by yourself, then you can easily use two functions, degrees and radians. Again, I would like to remind you, so pi radians is equal to 180 degrees. So this is the fundamental formula. If you know this formula, you can find everything. You can find degrees for other values of radians or vice versa. Now let's apply some of the trigonometry functions to compute by using degrees or radians. So let's check out together. Again, I would like to remind you that it's better to use this tool, insert function, so you can easily search for any function. Or if you don't want to do this, you can simply find a function inside a given category. Okay, so they are classified. For example, all these sine and cosine functions can be found here. Okay, so let's say, where is sine function? Okay, this is sine function. You can use help on this function, or you can just simply type something and it will return you the sine of a given angle. So here you will find some examples. Okay. So again, it has the following arguments. Actually, you'll have only one argument. So please don't forget, the angle here is in radians, not degrees. Okay, the angle is in radians. So let's say I want to compute sine, for example, sine of what? For example, sine of let's say pi radians. Pi. I will type pi. So don't forget, pi does not have any argument, right? So okay, it returns something like this one. Of course, we need to be careful with categories, and we need to use, I think, better to use decimal point. Okay, the answer is 0. Sine of pi, you know, pi is 180 degrees, right? Sine of 180 degrees, right, is sine of pi, right? Sine of pi. Sine pi is equal to 0. So you can find this from our formula, right? From our formula. Again, in trigonometric functions, so the argument will be considered as given in radians, okay? It's given in radians. So here, I will write here, radians, not degrees, okay? So this one is given in radians. If you want to compute in degrees, then you have to use degrees function as a nested function. We can also try to do this together. Okay, let me erase it. Okay, so this is radians, and then okay, let's see. Okay, I want to convert to radians, 30 degrees, for example. The same as I used here. So I will consider this as an angle and compute it in, convert it to radians. Enter. 0.5. Right. So sine of 30 degrees is equal to 1 over 2. Sine of 30 degrees is equal to 1 over 2. So we know this from our basic tables. So first of all, you need to convert this to radians. So please don't forget. For that purpose, I was using a radians function here. So in this case, this function is nested. So radians function is located inside sine function. So it's a nested function. I have explained to you nested functions in this week. So dear students, in the same way you can compute any other trigonometric functions like a cosine function, for example. Instead of sine we can use cosine, right? Enter, so you'll compute cosine, or you can find any other trigonometric function in this category. So you can find tangent, you can find arctangent, you can find arcsine function. So and all other trigonometric functions can be found here. So please pay some attention, because you know that trigonometry functions are also useful for engineers. So we engineers often use sine, cosine, and tangent functions. So they are very important for us. Again, trigonometry function. So please check out the glossary so that you can find the meaning of trigonometric. So the next functions are called exponential and logarithmic functions. So let me translate it here. So firstly, I'll translate exponential function, and the next one is logarithmic function. So I think in one of our lectures I have given you the meaning of exponents and logarithms. logarithmic function. Okay, exponential and logarithmic function. So these functions also usually studied in high schools here. So we will not study them as from the point of view of mathematics, but I will teach you how you can compute them. For example, how we can return exponents. What kind of exponents we can return? Let's say I want to compute a to the power of x, or for example 5 to the power of 2, for example, right? This is an exponent. Or 2.5 to the power of 3, right? Or e to the power of square, right? E is a mathematical constant, so you can also find its value in the internet. So e is a constant like pi number also. So you can call this Euler constant. Okay, now, so let me compute some of this. Again, a to the power of x or xn. Okay, let me create a new page, new sheet. Okay, for example, 2 to the power of 3, okay? 2 to the power of 3. So what does it mean? So we need to multiply 2 by itself 3 times. So 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, it is not computed. How about if we use equal sign here? Let's use equal sign and use enter. And as a result, you have the answer. Again, dear students, if you are working with any kind of formulas or computations, you have to use the equal sign. Okay? So without using equal sign, your computations will not work. So if you compute sine, you will use equal sign. If you compute logarithm, you will also use equal sign. The next example, okay, equal, let's say, if I use minus 2, let's say, to the power of 3. So minus 2 times minus 2 times minus 2. So let's say it will equal to minus 8. So you can easily compute very complex things here. So for example, 1.2 times 0.3. Okay, you see, very complex computations are quickly done actually in such electronic spreadsheets. So 1.2, right, to the power of 0.3, right? So I think by using your own brain, computing this will be very hard, right? But using spreadsheets and only one cell, we can easily get the answer. So try to do this by yourself. I think you can learn many things which can be useful for yourself. The next one is e to the power of something. I will use equal sign exp, x, for example, 1. Okay, so what does it mean? E means number e, right? This is a mathematical constant. E to the power of 1 is obviously equal to e, right? And approximately equal to 0.71, right? And also here is the continuation, right? So that will have 1, 8, 2, and 8. Actually, a very interesting number. This is birth year of famous Russian writer Leo Tolstoy. I think you might heard about this famous writer. So he was born in 1828. So in the same way, you can recompute it. So let's say you want to compute what is e to the power of 2. E square, x of 2, okay? So it means we compute here what is e to the power of 2, or e square. So you will have this value, right? So exponential functions are important also for mathematics, for engineering, and often we also need to deal with them. So the next thing is logarithm. Logarithm or logarithmic function. Logarithmic function. So again, if you don't understand what is a logarithm, please go to the previous lectures and watch it again. I have already given you the concept of logarithm. So a logarithm can have a base, okay? Base can be equal to 10, or it can be equal to e, right? Or it can be equal to any other number. So if base is equal to e, then we can call this a natural logarithm. Natural logarithm. So in mathematics, we usually write this in this way. So let's say logarithm, then we write a base, right? We write the base, for example, 5, right? And let's say 25, right? So how to compute this? What this value is equal to? So you can convert it to equation 5, right, to the power of unknown is equal to 25, right? So obviously unknown is equal to what? 5 to the power of 2, right? So this value is equal to 2. So if base is equal to e, so logarithm e, right, of let's say n, right, then you can call this a natural logarithm, and you can write in this way, ln of n, right, or ln of x. I'll write this way, in this way, okay, so that it will not be confusing. Also, base can be equal to 10, logarithm base is 10 of, let's say, x, right? In this case, we will use this function. So, but in general, I suggest you to study this one. So this is general. You can write a number here in the base, and it will return you the logarithm of a number to the base you specify. So let's do some small example. Again, logarithm. First of all, we'll write a number, and only then we'll write a base. Okay, equal log. So number is 25, base is 5. That's all. Enter. So what does it mean? So I have written, so logarithm, so number was 25, base was 5, right? And number is 25 is equal to 2, right? So you can easily compute any logarithm, and you don't need to use any slide rules. If you remember, when I explained logarithms, I've given you some pictures of slide rules scientists were using before. But now we can easily compute logarithms with any base. So again, this is a base. This is a base, and this is a number, okay? So base can be equal to 10, e, or any other number. Any other number. Okay. Of course, there are some restrictions, but you need to check your, I think, maths classes to better understand it. Okay, this is what I wanted to tell about logarithms. In the case of if base is e, then you can use ln function. ln function. In the case of base is equal to 10, then you can use log 10. So in this case, you'll have only one argument here. one argument. But in my opinion, it's better to use the more general function where you can specify both base and number. So that's more clear in my opinion. The next operation is called rounding. So here I have given you a translation. What is a rounding? I think this one is the correct one. So I remember a poem related to rounding. I will read it for you. Find your place, look next door, 5 or greater, add one more, all digits in front stay the same, and all digits behind, zeros your name. Example, round to nearest 10. So it means we need to consider this digit, right? So here, the next digit is 3, so we will round it to 60. So if 4, we'll have also 60 here. But if 65, then we can round it to 70, right? If 5, starting from 5. The next example, 5 to 4 becomes 5 to 0, right? Because this number is 4. 5 to 8 becomes 530, okay? Very simple examples. Also, you can find some examples on how to round to nearest 100, okay? So you need to consider this digit, right? This and this. 435 becomes 400. So it becomes 0, right? It becomes 0, and etc. I think you remember this operation from your high school, or even actually middle school. So we frequently need to round numbers in calculations. We may be attempting to follow the rules of significant numbers, or we may wish to avoid troubles resulting from binary round-off. So whatever the reason, Excel provides a variety of functions to round or truncate numbers. So this was only one example, and you should know this from your school. So if you want to apply it in Excel, then you will use round function. So round function will exactly do the same. Exactly the same, right? So here, so we will have 2 arguments. Again, round function will start with equal sign. It will start with equal sign, and here we will have 2 arguments. So the first one, so which is required, and number of digits, also required argument. So I think I have already shown you some example related to round. So then let's go to here to this page, and here you'll find an example. So let's say cell A1 contains 23,7825, and you want to round it to that value to 2 decimal places. So you want to have only 2 decimal places, only this one and this one, okay? So the question is what you will have. So the next digit here is 2, right? So it will become 0. As a result, you'll have 23,78. So this is what related to our round function. Moreover, I would like to teach you another round function, and so the name of this function is round up function, round up. So the syntax is exactly the same as for round function. Don't forget equal sign. So here we'll have a number, any real number that you want to be round up here, and then comma, right? And number of digits is also a required argument. So the number of digits you want to round. So this function will round a number up away from 0. Away from 0. So let's consider the following example. So round up 3.2. 3.2. So number of digits is 0. 0. So where is the 0 digit here? This digit, right? This is Okay. So we need to round it up, right? Round up to what? To 4. As a result, we'll have 4. The same here. So we will round this up until the number reaches 77. Okay. And in the next one, we will round up the first one, right? The first one. So we need to increase this digit, right? Until away from 0, right? So it will go up and then it will become what? 2, right? So as a result, we'll have minus 3 over 2. So you can also test this. I think I will do this when I will show you another function. So the next function is round down. Exactly the same syntax, but it will round a number down towards 0. Towards 0. Not away as a round up function, but towards 0. I will show you one more example here. So for example, 3.2. So we will work with this digit, right? So we should go down, right? So it will go towards 0. It will become 0. 3.0 is 3. The next one, 76.9 and 0 digits. So okay, this one will go towards 0. It becomes 0, so we'll have 76. And the next one is, I think, 3 here, right? 3. So the fourth one is this one. So this value will go down, right? Will decrease until 0. So we'll have 3.14 and 1, right? As shown here. So we can test these functions in Excel together. Again, round up, and round down. Okay, so first of all, let me input some numbers. Here I will use round function. Here I'll use round up, and here I will use round down. Round down function. Okay. Let me center it. Okay, here I will have let's say 1 point what? 1.12, 1.23, 1.25, and 5.48. Okay. Let me create a table using borders. So I will round up, let's say, okay, I will use the 1 digit, 2 digits, and etc. Okay, round this value and the first digit. Okay, enter. So I will copy this here and I will rename it round up, round up, round up, and here is round. Second, it should be I think it should be C3, right? Not D3. I forgot to make it absolute. C3, and this will be round down. Okay. So now you can see that I'm using the first digit, right? So the first digit. The second argument here is number of digits. So the same input, C3, 1.12, right? If you round it, so because of 2 here, we will have only 1, right? So 2 will disappear. We will round by the first digit. So round up. So 2 will go up, right? It will become 2 here, 1.2. round down, so 2 will go towards 0, will decrease. Instead of 2, we'll have 0. As a result, you'll have 1.1. Okay, the same here. Let me copy it. Let me copy here. I will simply copy. Okay. So you can see that different rounding functions, they can produce different result. Okay. So you need to be very careful. So let's say I want to use the 2 digits here, 2 digits. Here also I'll have C4, right? And I will have 2 digits. Also I'll have 2 digits here. Okay, so different results. Again, round up will round up away from 0, right? Away from 0. Okay, we'll just use here. Away from 0. So this will round down towards 0. Towards 0. Okay, this is the difference. So I hope you understand the concept of this. So also, dear students, we have much more functions which are related to rounding. For example, odd, or even, or ceiling math, or floor math, int, truncate also. But I think we will not concentrate on these functions. But if you're interested, of course, you can check page 61 of your textbook. You can simply do some examples. So other mathematical functions are listed here. Again, pi function, it will return you the constant pi, so which is an important constant. So as you know, constants are often used in the field of mathematics. And the next function is SUM_SQ. It returns the sum of squares of range of numbers. Also we have SUM_product, which returns the sum of the products of the elements of 2. And already you know what is a square root. It will return the square root of a positive number. So I will not have any examples related to this, but if you are interested, you can easily check what kind of functions they are. For example, you can call here, then right here, SUM_SQ, right? SUM_SQ, and go. You will find this function in here. So it will return the sum of the squares of the arguments. You can also click on the help and find some appropriate example. Actually, from this example, you can easily understand how it works. So here, so there are 2 arguments, but you can have until 256 arguments, right? So 256 arguments is a maximum number. So don't forget to use comma, right? Comma to separate arguments. This is a comma. So sum of squares of 3 and 5 is equal to 25. So how do we compute? So the first argument, SUM_SQ, right? 3 and 4. Sum of squares. So first of all, we need to use squares. So 3 square, right? Sum means plus. Plus 4 square is equal to, result is 25, or is equal to 5 square also. Okay. In the same way, you can compute any other sums. So sometimes these formulas are also kind of useful. Again, pay attention to SUM_product also, which will return the sum of the products. The next one is a square root of pi, right? So actually is equivalent to this formula. So if you don't want to type this one, SQRT, 2 times pi, you can simply use sqrt_pi function. Actually, these are equivalent. I'm not sure if you would be interested in using this, so I would prefer to use sqrt function because it's quite simple. The next important function is a factorial function. Factorial function. Factorials are also often used in computation. Factorial. For example, if you want to compute a factorial of 4, so usually for factorials we use exclamation mark. So we type 4 and then exclamation mark. So is equal to 4 times 3 times 2 times 1 is equal to 24. Okay? So you can compute factorial of any number by using fact command. Fact, let's see, I want to compute the factorial of what? The factorial of equal fact, let's say 10, factorial of 10. So it means 10 times 9 times 8 times 7 times 6 and until 1, right? So the syntax is very simple. You will start with equal sign, then type fact and use 10. Enter. And you will get this result. So if you use a calculator, it will be very hard to compute this. It will take a lot of time. So you need to type 10, then times 9, times 8, and etc. But here you will use only one simple function called fact function. So moreover, we have GCD function. It returns greatest common divisor. Common divisor. So I will not show any examples related to this because already example is given here. So you will type GCD, for example, 9, 18, 24. They have greatest common divisor, which is equal to 3. Okay. So I think you remember such problems from your schools. So the next important things, dear students, I would like to provide you with some commands, with some functions which are useful for working with matrices. So you know what is a matrix, or you don't know what is a matrix yet, but in your class related to linear algebra, your professor may ask you to compute matrices in Excel or any other software, and then you can remember my lecture. So what is a matrix, dear students? Again, matrix is an array of numbers. Array of numbers. Okay? So here you will see array of numbers. So I have A11, A12, and etc. Okay, so in here matrix has rows. Actually, in Excel we also have rows. So how many rows do we have here? So the first number here computes the number of rows. For example, the first number is the first row, right? The first row. Then the second row, then the third row, and row number m. So m row, okay, mth row. Also we have columns. So the second number in subscript, so this is a subscript, right, shows the number of column. So the first column, and this is the same first column. So then we have the second column, right, 2, 2, 2. And finally, we have the end column, right? End column. So we have a table of numbers, array of numbers. So we have m rows and n columns. So the size of this matrix is m by n. Okay, m by n. So this is not a multiplication. So m by n means the size of this matrix. Again, matrix is an array of numbers, so please don't forget this. Very simple definition. So how do you write matrices? So we can use parentheses, like shown here, right? Parentheses. Or we can use square brackets. Square brackets. So both of them will be fine. So if you write it this way, all of them are acceptable. So they have the same numbers, the same elements as shown here. So what are the applications of matrices, dear students? Actually, matrices have a lot of different applications, and engineering is one good field where we can apply them. So for example, look here. So we have what? We have some square here. How many rows do we have here? How many rows? We have what? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? We have 10, right? 10 by 10. 10 by 10. So this is a matrix 10 by 10, right? So you can call this a square matrix. Square matrix. And here we have elements, right? So elements in the first column, the second column, and etc. And here we have rows. 10 rows and 10 columns. Actually, you can easily create this in Excel. You can very easily create. But here, as you can see, for each number, we assign different color. We assign different color. So 2 is blue, 3 is navy, 5 is some kind of green, right? Light green. So 9 is orange, and 11 is what? 11 is red. So such kind of visualizations are often used by engineers. So we call them visualization. So instead of numbers, we can apply colors by using some color map. So this is a color map. Color map. Yes, you can see it here. So we start with cool colors, dark blue, until we go to dark red color. So this is a color map. So also, as you know, so every picture is a matrix actually. Every picture is a matrix. So therefore, actually, matrices are important for computer graphics. For computer graphics. And you know, computer graphics is applied to almost all areas of engineering. So it's very, very important field in nowadays. So here we have some pixel, or you can call this a cell, right? Pixel. So in images, in pictures, we can see pixels, but in matrix we have element, or in Excel we have a cell, right? This is a cell, small cell. So every pixel will have some color, like shown here. By coloring pixels, we can generate some interesting pictures, like shown here. So also, if you use more columns and rows, you can create a detailed picture. So if you want to have more details, then you need to have more columns and more rows. So here we use only 10 rows and 10 columns, but here we use 20 rows and 20 columns. So if you want to have a good image, then you need to have higher number of pixels, right? I think also you may understand this. So what kind of commands, what kind of functions are used in Excel to work with matrices? Actually, here you need to understand some important operations with matrices. operations with matrices. If you study the class of linear algebra, then you can understand many operations. So here I will not teach you these operations. I want to teach you only those functions which can be useful. So first of all, for mmult can be used for matrix multiplication. So what does it mean? You can define two matrices. Let's say you will define two matrices, for example 1, 2, 3, 4. Okay, suppose this is your matrix, and I think we can also use in this way. Okay, this is your matrix. Let's say this is matrix A. I can define a name here. So matrix A, matrix A, right? So then you will define matrix B, okay, and you can multiply them by using mmult. Let's say this is your matrix. Okay. Again, I will use. Okay, here I will define it as a matrix B. Matrix B, enter. Okay, now it works. So if I select it, I have a name, right? Matrix A. And here I have matrix B, right? So this is matrix A. I will just write some name here, matrix B. So if you want to multiply, so matrix A, right? A has a size 3 by 3. So 3 rows, right? 1, 2, 3, and 3 columns. 1, 2, 3. 3 by 3. And matrix B has the size of 3 by 1. So 3 rows, right? And 1 column, only 1 column. So if you want to multiply them, so two numbers should match. I will show you which number should match. So this number should be equal to this number. Otherwise, you cannot multiply. So if it's not equal, then you cannot multiply it. So if these numbers are equal, then you will get matrix C with the size 3. 3 comes from here, and by 1, right? 1 comes from here. So 3 by 1, okay? So we will have 3 rows, right? And we'll have 1 column. Okay, here. This is C. Okay, I will use the okay. So for this operation you can use mmult function, mmult. So I will select these 3 cells, then I will use a formula bar and type the function here. So let's say equal mmult, okay? Then the first matrix, what is the name? Matrix A, right? Matrix A, comma, then matrix B, right? Don't forget to close parentheses. And dear students, important note here, a very, very important note. So if you compute one cell, you press only enter, okay? But if you compute, or if you want to compute the range of cells, means several cells. For now, I want to compute 3 cells. So I have to use Control, Shift, and Enter. So I need to press three buttons together. Okay, Control Shift Enter. Okay, it didn't work. So let me try again. I will select it and mult. So you need to be very careful. Okay, I will select in this way, I think. And now I will select in this way. Okay, Control Shift Enter. Okay, strange. Okay, now it works. So you need to carefully press Control Shift and Enter together. Okay, so simultaneously. So if there is some delay in pressing this one of these buttons, then you cannot compute it. So we got matrix C, and the size of this matrix is 3 rows, right, and 1 column. So 3 by 1. Okay, so again, use Control Shift and Enter. So if you want to compute several cells, or you can call this a range of cells. So other matrices, also for other matrices, you can use the same approach, right? So for example, you can generate an n by n unit matrix. Unit matrix, it means some spatial matrix. Also, you can find an inverse matrix. Inverse matrix. I'm not sure if you understand this concept, but I will try to show this to you. Maybe it can be useful for your other classes. Also, you can compute a determinant. For computing the determinant, so you need to press only Enter. Okay. Here, for example, for this one, you will use Control plus Shift plus Enter. Why? Because we compute several cells here, and for this function mdeterm, you will use only Enter. Only Enter, and it will help you to compute the determinant. Thank you for your attention and have a good day.